Hello, so I'm going to discuss the topic how are memories being stored. So this topic will answer the questions where in the brain are memories stored and what structure and areas of the brain are involved in memory process such as encoding and retrieval. Many attempts at localization of memory were unfruitful. The renowned neuropsychologist Carl Lashley in 1950 he reluctantly stated that he could not find specific location in the brain for specific memories after literally hundreds of experiments he conducted. But in decades later, after his admission, psychologists have located many cerebral structures involved in memory. For example, they know of the importance of the hippocampus and other nearby structures. However, the physiological structure may not be such. We will find Leslie's elusive localization of specific ideas, thoughts, and or events. Even Finfield's finding regarding links between electrical stimulation and episodic memory of events have been subject to questions. Some studies show encouraging, although preliminary, findings regarding the structures may seem to be involved in various aspects of memory. First, the specific sensory properties of given experience appear to be organized across various areas of cerebral cortex. For example, the visual, spatial, and olfactory or odor features of an experience may be stored discretely in each of areas of the cortex responsible for processing each type of sensation. Thus, the cerebral cortex appears to play an important role in memory in terms of the long-term storage of information. In addition to this, the hippocampus and some related nearby cerebral structures appear to be important for explicit memory of experiences and other declarative information. So, its main function appears to be in integration and consolidation of separate sensory information as well as spatial orientation and memory. But the most important is it is involved in the transfer of newly synthesized information in long-term structure supporting declarative knowledge. So the hippocampus is responsible for encoding new information into long-term memory. And this declarative knowledge are those information that can be consciously retrieved or declared. In evolutionary terms, the aforementioned cerebral structures, chiefly the cortex and the hippocampus, are relatively recent acquisitions. Declarative memory also may be considered a relatively recent phenomenon. At the same time, other memory structures may be responsible for non-declarative forms of memory. For example, the basal ganglia. It seemed to be the primary structure controlling procedural knowledge. Procedural knowledge are those, on how we perform a task or a skill. The other one, we have the cerebellum. It seemed to play a key role in memory for classical conditioned responses and contributes to many cognitive tasks in general. The amygdala is often associated with emotional events. So, in one study of Cahill et al. 1996, participants saw two videos presentation represented on separate days. This video involved 12 clippings, the first half of which had been judged as involving relatively emotional content and the other half is involving relatively unemotional content. As participants watched the video clippings, brain activity was assessed by means of PET or the positron emission tomography scan, which was already discussed in chapter 2. After a gap of 3 weeks, the participants returned to the lab and were asked to recall the clips. For relatively emotional clips, amounts of activation in the amygdala was associated with recall. For the relatively unemotional clips, there was no association. So these results suggest that When memories are emotionally charged, the level of amygdala activation is associated with recall. In other words, the more emotional charged the emotional memory, the greater the probability of the memory will later be retrieved. The amygdala also appears to play an important role in memory consolidation, especially where emotional experience is involved. In addition to these preliminary insights regarding the macro level structure of memory, we are beginning to understand the microstructure of memory. For example, we also know that some neurotransmitters disrupt memory storage, while others enhance memory storage. Both serotonin and acetylcholine seem to enhance neural transmission associated with memory, and the norepinephrine may do so. The acetylcholine have been found in the hippocampus of normal people, but low in people with Alzheimer's disease. In fact, one study about Alzheimer's patients shows severe loss of brain tissue that secretes acetylcholine. The serotonin also other form, I mean, play a role in other form of memory dysfunction called the Korsakoff syndrome. The severe and prolonged abuse of alcohol can lead to this devastating form of antegrade amnesia. Alcohol consumption has been shown to disrupt the activity of the serotonin, and it thereby impairs the formation of memories, according to Wiegafner et al. 1983. This syndrome also has been linked to damage in the diencephalon of the brain. The diencephalon is the region of the brain comprising the thalamus and the hypothalamus. Also been linked to dysfunction or damage in other areas such as in frontal and temporal lobes of the cortex, which we already know. The frontal lobes are for those higher thoughts processing like abstract reasoning and problem solving, while the temporal lobes is associated with the auditory processing. Other physiological factors also affect memory functions. Some of naturally occurring hormones stimulated increased ability of glucose in the brain, which enhances memory functions. So these hormones are often associated with highly arousing events such as traumas, first-time experiences, achievements, and other big moments. So these hormones play an important role in remembering these events. Some of the most fascinating research in cognitive psychology focus on strategies used in regard to memory strategies, and memory processes are the subject of the following chapter. That ends my report. Thank you.